So we're going to get into thermodynamics as it relates to work done by or on a system, pressure, and volume questions. So for right now, I only have 2 questions, but for other videos, of course, I will be doing more questions so I can help you guys with your exams and so on. So when work is being done on a system, compression occurs, and that is basically made true by a system such as this one, which involves a piston. And a piston is basically a machine that pushes down like a cover over a container, and it pushes down to increase pressure, goes up to decrease pressure. So in this case, when the piston is pushing down, applying force into the container, volume decreases. So volume decreases and the pressure increases. Right? So as you're going down, as you can imagine, all the particles are being stressed as it goes down on all these particles that don't have any escape out of the container, and as such the pressure within the container will build up because the particles are hitting the size of the container as well as each other at a faster rate, and this builds up the pressure within this system. However, if it is a case where there is a situation where the system, whatever reaction is taking place in the system is pushing the piston back up, a reverse reaction, right? This is where you have work being done by the system. So the particles within the system are reacting on their own through a chemical reaction or something that is increasing the amount of, for example, particles, oxygen, carbon dioxide within the system that is going to be pushing the piston upwards. So this increases the volume, but the pressure decreases. So this is what I meant when I say that work is being done by or on the system. So as you can see, pressure and volume are inversely proportional quantities against each other. So for this question, it says, sketch a pressure volume diagram to show the isothermal. Isothermal means constant temperature in a system, so the temperature doesn't change, it is under control. And isobaric means that the pressure is constant as well. Expansion of a gas from 24 to 38 dm cubes. So the keyword right here is expansion. As I said before, expansion is when work is being done by a system. So this means that as volume increases, pressure decreases, right? So let's sketch this diagram, which would be pressure would be on the y-axis and volume would be on the x-axis. So the pressure in this case, the starting pressure would be at 0.99 atmospheres. Apologies, but you know what I'm getting at though, because pen is not really cooperating. And the volume would be from 24 dm cubes to 38. When you're doing questions like this, ensure to put your units as well as label your axes and so on and so forth. This is just for demonstrative purposes. So as it says, expansion of a gas from 24 to 38. So when you're doing questions like this, you're supposed to understand the relationship between pressure and volume. So you know that this volume is increasing from 24 to 38 dm cubes. So as such, the pressure would be at a higher value up here at 0.99, and it decreases going down as the volume increases because work is being done by the system. And this is just a simple answer for this question, right? However, when you get questions like as it relates to calculations, right? You have to think about the relationship between pressure and volume as well. However, you have to know the type of equation you're going to use. So it says that if 3 moles of a gas expands isothermally, isothermal means, as I said before, constant temperature. In this case, it would be 298 kelvins. That's a conversion from 25 degrees Celsius. from 30 to 50 dm cubes while its pressure is also changing. What are the corresponding pressure values for this process? So when you're trying to figure out which equation to use for a question, you have to think about the variables or the values you are given from the question. So you're given the number of moles, you're given a constant temperature, and you're also given a change in volume. And the pressure is also changing. When you're thinking about constant temperature and you're dealing with moles, pressure, and volume, you have to think about the ideal equation, the PV equal nRT equation. So let me get it right here. So it's PV equal nRT. So this is the equation we're going to be using to calculate the corresponding pressure values for this process. So as you all know, as I said before, in this case, pressure is going to be decreasing from a high value to a low value because the volume is increasing because they're inversely proportional to each other. So the pressure you calculate for the 30 dm cube volume should be higher than the pressure you calculate for the 50 dm cube volume. And that is how you will know if your answer is correct. You have to think about what is happening in this reaction. And as such, you can draw a PV diagram to try and see if you can understand stuff better because I know it can be a bit confusing. So you're going to draw both your volumes. You don't know the pressure as yet, however, you should know where the pressure levels are going to be on a hypothetical basis. So in this case, for example, the pressure is going to be up here because it's going to be higher than the volume that you're going to get after. So you know it's supposed to be decreasing because volume is increasing, right? They're inversely proportional relationships to each other. So let's get right into it. All right. So let's do the one for the 30 dm cubes first, right? And I'm just gonna do a little rundown of this. I'm not gonna really get into it. But the thing is that you should know your units, right? Um you should know units for each variable you're using in your question so you can get full marks. And that is how you're gonna figure out if your answer is correct as well. Because sometimes whenever you're calculating a question, you know the final unit that you're supposed to have, so you can use the units to help you figure out if the answer you get for your question is correct, based on what is being cancelled, what is being squared, and so on and so forth. So for the 30 dm cubes, you're going to transpose this equation because you're trying to find the pressure. This is what you're trying to calculate in the question, the pressure values for the process. So it's going to be P equal nRT divided by the volume. So you're trying to find the pressure, corresponding pressure for. So the volume in this case we're going to be working with first is 30. So it's going to be P equal the number of moles, which is 3, right? I'm going to multiply it by the constant R, which is 8.314. The unit for R is joules per mole per Kelvin. So this means that you have to convert this to Kelvin, right? You have to ensure that your units are matching so you can cancel accordingly. And if they don't match, you're not going to get the correct answer as well. So convert accordingly. I'm going to multiply by the temperature. So you're going to convert 25 degrees Celsius to 298. You have to add 25 to 273. Get temperature in Kelvin. I'm going to divide by the 30 dm cubes. When you calculate, put this in your calculator. You should get 247.75. I can say 248 pascals, right? This is the value for the first part of the question, right? So it's for the 30 dm cubes. So we're going to calculate the pressure value for the 50 dm cubes. And as I said before, the pressure value you get for that one is supposed to be less than this one. Because as I said, as volume increases, pressure decreases in the process. So we're going to use the same equation, of course, P equal nRT divided by V. However, the only difference we're going to have is the difference in volume, so it's going to be 50 instead. So when we do that, when you divide it by 50, you're going to get 149 pascals. So as you can see, for 30, it's 248, and for 50, it's 149 pascals. So that is basically the answer for this question. And as we did before, we draw for the pressure volume diagram. It correlates with our answer for this question because as you can see before, what we did before, as volume increases, pressure decreases. That is basically it for this question. More questions as it relates to thermodynamics are going to be posted, so stay tuned for those, and like, comment, share, and subscribe.